Hello everyone, I'm back with another Leetcode video. Today I'm doing a minimum height trees. This problem is, let me just see, topological sort. Well, it is a kind of breadth first search, topological breadth first search maybe. Let's read the problem first, okay? A tree is an undirected graph in which any two vertices are connected by exactly one path. In other words, any connected graph without simple cycles is a tree. Okay, not very relevant, or it may be. Given a tree of n nodes labeled from 0 to n minus 1 and an array of edges where this represents an edge between two nodes. It says there is an undirected and you can choose any node of the tree as the root. When you select the node x as the root, the result tree has height h. Among all possible rooted trees, those with the minimum height are called minimum height trees, and we have to return the list of all minimum height tree roots. You can return answer in any order. Okay, for example, in this example we have four nodes, and these are the edges. And node 1 is the result. That means when we choose node 1 as our root, it will produce the tree which would have the minimum height of all the all these possible combinations. Yeah, and in this example we have 6 nodes, and 3 and 4 is the answer. 3 and 4 are 2 nodes. When used as nodes, give minimum height trees. Okay, and other than that, let me just see. We have a hint here, but it's not really useful. How many minimum trees can a graph have? How many minimum height trees can a graph have at most? I don't know about that, but the main idea to solve this problem is to we want to basically eliminate the leaf nodes first. Imagine we are starting from the leaf nodes, right? We start from the outer boundary of the tree and we get rid of the leaf nodes. For here, for example, 0 to 1 are the leaves, so I get rid of this, I get rid of this, I get rid of this, and from my leaf nodes I move inwards. I move towards the root from 3 directions, and by directions I'm thinking of well, what algorithm should I use to do this, basically to get rid of the leaves and then move inward towards the root. Depth first search, no, I mean breadth first search, because it's very similar to how we do what do you call multi-source depth first search. So I'm thinking of doing that, and really in this example we only have like 3 leaves and there is only one level. But when we have a tree of many levels, or should I say degrees, yeah, when it is not, when we don't find the roots or the minimum height trees we're looking for immediately, once we get rid of the leaf nodes, we will most likely find ourselves more leaf nodes. So we have to get rid of those as well, and we just keep doing this process. We keep cutting down the leaves until we have 1 or 2 nodes, and those are going to be the nodes that I need in my result. Why this works, you can read about this. I actually watched a very good video on this on YouTube, and this is really the practice part. So it works. Okay. Yeah, so let's now solve this. Okay. How should I do this? Well, I'm gonna make use of breadth first search I mean, and for that I'm gonna need a queue. Other than that, we are given the nodes, right, and we have edges, but we can't really make any use of this thing. We have to first convert this into a graph. So for graph, say my graph is going to be the array of mutable lists, mutable list of integers. Like this, and I'm gonna edge. I want to check my edges. Iterate. For creating this graph, I edge this dot add this, and where's my edge? This. Result is my mutable list of int, and I'm just gonna return this for this list here, result. And I will let me just check my graph. Okay, I can't really print it like this. Graph for each println t. Okay, yeah. Now this is something I can really use. This is just the 2D array representing, you know, edges, but I can't really make any use of this. Here I have well, here my index represents the node, and the list represents the list of node represents the nodes that my index node is connected to. So for example, here at index 0 there is only one node, so that means 0 and 1 are connected like this. Here 1 is connected to 0, 2 and 3, just like this, and yeah, that's it. Now I need to find the degree well, and from here I can also get the leaf nodes. It's very easy to get a leaf node. A node with the 1 degree is the leaf, so 0 and 0 1 no 0 2 3 0 2 3 are the leaf nodes. So yeah, first of all, let's leaves. I'm gonna say leaves. I will have my leaves here, leaves, and I also need a degree list. It's a list of I'm gonna say graph. Well, let me see what I want. I want to filter this list. Yes, filter. My degree, yeah, I want to filter this list, and this is the lambda I'm passing. Basically, I want the element with hang on. No, actually I don't want to filter. I want degree. I want all the elements, but I just want their sizes. I want the size of the list. Degree. How do I do that in Kotlin in a nice way? I don't know. Maybe. Okay, graph dot. Maybe I should use map. I want to apply this function size, and here, okay, let me just print this first of all. Graph, just say this, okay. Filter. Actually, let me just first of all see this. See the result of the degree. Okay, yeah, nice. This is what I wanted. Yep. Now I want to get all these leaf nodes. A leaf node is leaf node is one whose degree, leaf node is the one whose degree is 1. So I can just say wall leaves is a degree, but I want the index, right? So indices, right? Indices. I think this is the right thing to do. Leaves. Okay. Indices degree dot indices. Let me just ask ChatGPT. What's wrong with leaves? Indices is not a function, it's a property. You can't pass. Okay, it's okay. Right. Indices is not a function. Sorry, it's not a function. It's a property. Dot filter. Must use filter after degree. Okay. That took a lot of time. Okay, now I have my leaf nodes. These are the leaf nodes I need to eliminate. Okay. Now I have the leaves, I have my degree. Maybe I should make this leaves into a priority queue. So while true, and let's say a size, something like I know I need some kind of size here, but I'm not sure what. Oh, it should be by the way, by getting the leaves, I'm going to check their neighbors. But not sure how it should be done. Let's see. Let's try to find that out. So I have my leaves, I have my degree, and plus when I eliminate the leaves, I must also reduce the degree here. Yeah, also not sure how to do that. Can I do this? Can I wall priority queue is leaves. Can I do this? I don't know. Let's see. pq.size, while size is greater than 2. Oh yeah, I can do this. That's great. That's great. Well, leaf is getting a leaf is now as easy as just polling from the queue. And okay, what should I do with this leaf? This is a node, right? Well, I must decrease its degree, so degree leaf minus minus, something like this. And I think I should also check if the degree is still greater than 1. Then that means, hang on, not now. Let me first of all, let me check the all the neighbors of this leaf. So for example, if it's a 0, I will try to visit all its neighbors. Why should we do that? Well, if it's a 0, then I'll visit 1. 1 has a degree of 3, so it's not really a leaf. Graph and leaf neighbor. I think is this how we do this? Sorry, I'm just not good with Kotlin yet. 0 in graph, neighbor in graph. Okay, what should we do next? Topological sort. Exactly that. Okay. So let me just see. Let me just take a look at the inputs again. In this example, my leaves are gonna be 0, 1. No. Well, I'll start with 5. Or in this example, 0, 1, 2. Who are the neighbors of 0? There is only 3. What should I do with that? What can I do with this information? Who's the oh, I got it. I think I got it. So I'm visiting this, I'm on this 0, and I'll probably go here at 3. I need to remove this connection. Yes, I got it. Degree of the neighbor, actually, minus minus, and if the degree of this neighbor becomes 1, then that means this node has also become a leaf now. So I must add this into my priority queue of our neighbor. Need this here. but this is not quite right. Okay, where was I? Okay, yeah, so we got rid of we get rid of 0. Now the problem this 3 has a degree of 3 when we are at 0, then we visit 3, we cut this connection between 0 and 3, but when we cut this, its degree is still 2, so yeah, it will not be considered for it will not get added to my priority queue. This connection will not hit basically, and then I have 1, then I again visit 3, we cut this connection again. Will I visit no, actually 3 has the degree of 4. Yes, so once all of these all 3 of these get rid of then my 3 will get added to this priority queue. Here 5 is the only leaf, and when we visit 4 has a degree of what? 2. When we get rid of 5 from here, it will only have the degree of 1. And does that means 4 also becomes a leaf? No, so I can say that as long as my priority queue's size is greater than 2, as soon as it becomes 2 or less, then that means I have found my answer, and I can just return this priority queue to list. I don't know if it will work. Line number 16. Oh, I didn't have this error before, so that means there is something wrong elsewhere. Wait, I can't iterate over this graph? Okay. Just okay. Why am I not able to iterate over the graph? Because multiple labels, one structural issue. Okay. Yeah, for neighbor in graph, this is Java syntax. I can't use Java syntax here. Neighbor, and this is okay. But I still can't do this. Left. Line number 16. For neighbor in graph, left leaf. Okay. Just one last one. Line number 17. What? Unresolved reference. None of the following candidate is applicates. What do you okay. It's an immutable list. Yes, sure. Okay. I have to make this an int array. Okay. Not really what I expected. Well, I'm not sure how to proceed from here. I don't know what I'm doing wrong. Okay. How should I do topological sort using breadth first search to find minimum height trees? Can't have a version of start from all leaves of remove them level by level. Last, because we are removing nodes with degree 1, like removing 0. So it's basically topology. Step build graph, compute degree of each node, push all leaves into queue, remove current leaf, reduce neighbor degrees, leaves remaining node. Okay, I need to check the total remaining nodes. Remaining nodes is going to be equal to n. I don't want my queue size. Alright. Okay. Remaining node, is equal to pq dot size. Okay, and then I'm visiting the neighbors of the leaves, and then reducing the degrees, and then adding new neighbors into the queue. Okay, 2 3, getting 2 3 for some reason. I'm using a priority queue. Is that okay? Like, that is not okay. That is not okay. Why am I even using priority queue here? Array DQ. Now, oh no, pole. So there is no pole here. Okay, remove first. Is it? Hang on. Let me just print my queue here. PQ. So it has 0 2 3. I mean, priority queue could also have worked. Priority queue is min heap by default, and in this too we are okay, let's just keep it q array dq. let's just go with Q. Degree, and then leaves, then Y, 2 and 3 is my answer. So I'm basically getting these answers. There are total n nodes in this graph, and n minus priority queue size. Oh no, size is PQ size. Size. Okay. I need one more loop in this. Yeah, of course I need one more loop. That's how can I that's the basic step in the most basic step in breadth first search. How can I miss this? Okay, alright, I think it should work now. This is an edge case. If n is smaller than 2, return the result. Expected 0. I know it's not right syntax, but just bear with me, guys. How do I have a list of 0? Yes. What? List of 0 is not right? What? Is smaller than 2. Okay, the algorithm is not right. I'm doing something wrong somewhere. Let me just array just list leaves is map index not null. Okay, remaining leaves, new leaves is a mutable list of leaves is a mutable list. for leaves. We don't really need a queue. But no, it's kind of doing the same thing here, just with the queue. I'm not sure what I'm doing wrong. Okay, so I'm really too tired to find out why it's not working. So I'm just gonna, I don't know. I'm just gonna ask. What's wrong here? Only one critical bug. This does not mean subtract. What? Oh. Yeah. Did not know it was possible. Yep. Cool. That was it. Thank you for watching this video, guys. Bye bye.